Let's.
September.
Okay. Hi, my name is Ray Cromwell. Can everybody hear me back there? Mm-hmm. Okay. Yeah. So as mentioned before, I am tech lead for GWT, and what I wanted to show you today, if you haven't heard about it, is some of the new features that are in GWT 2.5. Just for a show of hands, how many of you have heard of Super Dev Mode and/or Elemental? Okay, that's good. So some of you will be seeing this for the first time. Okay. First of all, how many people here know what regular Dev Mode is, or have used the GMT Dev Mode before? And so, if you haven't used it before, essentially what it does is you write your code in Java for GWT, and you want to preview it in the browser before compiling it. So what we do is we run the Java code in the JVM itself, so it runs as native JVM bytecode. However, whenever there's a call to do something actually in the browser, like create a DOM element and append it, it has to call out to an actual live web browser. So the way we do that is we've got this plugin written in C++ that runs in various browsers like Chrome, Firefox, and IE. So this is kind of a diagram of the way it works. So you've got your actual like pure Java code running in here at like full speed in like the hotspot VM. And then every once in a while you hit a method like, add an event listener to an element or something like that, and it basically that essentially connects via TCP socket to the Dev Mode plugin, which is running inside your browser, and sends back across the message. It says, please evaluate this bit of JavaScript for me. And then it gets back a return result. Sometimes the JavaScript actually wants to make a call from JavaScript to Java, in which case there's a message that's sent back from the Dev Mode plugin to the JVM, which says, I want to invoke this Java method that's running inside the JVM. So that's basically how it works at a high level. Of course, there's a lot of black magic that happens in there, a lot of weirdo class bytecode rewriting stuff that I don't like to mess around with. So here are the benefits of this. First of all, there's no compilation. So if you're using something like Eclipse and you edit a Java file, Eclipse recompiles it on the fly, you hit refresh, and basically you rely on the JVM being able to reload that class. JVM code runs really fast, something like 6 times to 10 times faster in JavaScript. So if you have like really performance sensitive code, it's both a plus and a minus, because sometimes it can give you a false sense of how your app's actually going to run once it's actually running in the browser, especially on an older browser like IE6. But you can debug in your favorite Java debugger. So if you're using Eclipse, you're using IntelliJ IDEA, using NetBeans, you just use what you're used to. Here are the downsides though. Because we're using TCP/IP to set up a communications channel between the JVM and the browser, if you have lots and lots and lots of calls back and forth between the browser and between the GWT code, it can get really slow. As an example, let's say you create like a native JavaScript array, and you want to fill it with like 10,000 or 100,000 elements. So you do a loop like for I = 0 to like 100,000, and you call like array.push, and you push a value into it. That's going to create like 100,000 TCP packets round-tripping to back and forth to the browser, one for each like synchronous call to the JavaScript. And so usually it's not a problem, but like for example when we ported Quake to the web, I don't know if any of you have seen GWT Quake, but all of the graphics calls that are happening like 60 times per second, drawing all of those triangles, made it really untenable to run that within Dev Mode itself. But here's the real problem for us. This architecture forces Google to maintain, and now the GWT Steering Committee, to maintain 3 implementations of this plugin. One for Firefox, one for Chrome, and one for IE. We used to have like Opera and Safari support, but there's one away. On 3 different platforms, Linux, Windows, and OS X. And if we had a really large team at Google to do this, maybe we could put a lot of people on it, but obviously it's a problem. But here's the real problem. It used to be that like Firefox and IE, they would release a new browser like once a year, sometimes even greater gap. And so now, basically because of what Chrome has done, everyone's releasing browsers like on a weekly basis. Like every 6 weeks a new version of Chrome gets pushed out to everybody. And Firefox has been forced to play catch up. So now new versions of Firefox are rolling out every couple of weeks. And every single time they roll out one of these new version changes in their browser, they tend to break these plugin APIs that we're using for these C++ native plugins that hook into the browser internals. So now, almost every single time, like Firefox, 11, 12, 13, 14, 15, 16, every single time, without fail, it breaks the Firefox plugin, the Firefox plugin. Likewise, Chrome has also broken us a couple of times. And some browsers like Safari, they've removed the APIs altogether. So it's actually impossible to craft a dev mode plugin now for Safari. They've totally removed those APIs. And if you look at mobile browsers, like a lot of development now is moving to the mobile web, Apple doesn't let you write plugins for mobile Safari, forget it. So that's just a non-starter. We really can't keep up anymore updating these browser plugins for all the browsers on multiple platforms. It's just too much work, too much hassle. So we need to find a solution for this. And the solution is Super Dev Mode. So what Super Dev Mode is it's a pure JavaScript, no plugin approach to basically doing a fast edit refresh cycle with GWT. So if you've used GWT, you know that the compiles can take a long time. If you've got like a really modest app, they can take minutes. If it's a really giant one, like just to give you a figure, at Google AdWords, which is one of the biggest, it's like over 1 million lines of code, takes about 900 seconds to compile. And so you won't want to set at your desk and you make a change and you have to wait 900 seconds to see it. That's just going to be a non-starter. So we need to radically increase the speed of the compiler to the point where it can achieve a refresh in less than 10 seconds. That's the first thing. The second thing is, since it's no longer going to be running the code in the JVM, we need a new debugging story, because you can't just attach your Eclipse Java debugger anymore. And so one of the recent innovations in the browser has been to support source maps. And so what source maps are is that whenever you compile any language to JavaScript, GWT's just one example, but there's CoffeeScript out there. Microsoft's got this new thing called TypeScript. There's like umpteen different languages that compile to JavaScript now. And so they needed a way to create a mapping between the original source and the optimized obfuscated source, such that if you were stepping through it in the debugger and you're looking at it, you set a breakpoint, it can actually show you the original source lines. And so that's what it is. It's essentially bidirectional mapping. And it allows you to debug Java, for example, in the web browser. But you do lose your IDE JVM debugger. So there is a downside. However, you actually gain something. If you've done a lot of GWT debugging over the years, you're probably aware of this, but whenever you hit some JISNY code, whenever you hit a method that's calling into JavaScript, you basically hit a wall in the dev mode plugin. This happens a lot frustratingly in places like IE6 development, where you get some kind of weird exception. Usually it's like minus 200, it's like minus 2 million something, some weird numeric exception comes out of IE6. And you want to debug it, and you're stepping through Java, and you get to a point where it's doing something like appending a DOM element, and then you can't go any further. Then your only choice then is to basically compile it to JavaScript and go debug it in like the IE script debugger. And so what you gain from this is actually the ability to step into from Java code step into JavaScript. And in fact, it can actually work seamlessly with multiple languages. So if you've got like CoffeeScript in the page, or Dart, or some other language that compiles to JS, you can literally step from Java code into CoffeeScript or into Dart between languages themselves. It also lets you set DOM mutation breakpoints. So you can say, what's the bit of code that's modifying this part on the screen? So you right-click on an element on the screen, say set a breakpoint, and then the minute some piece of code in your application pokes that element on the screen, it triggers a breakpoint and shows you the exact line of Java code. That was not available before with your JVM developer. You can also set breakpoints like, when someone does mouse wheel up, immediately break into the code that handles that. And if you get an XHR callback, you can say break on it immediately. Okay. The other problem is that with the regular dev mode, or often there was code that had the special case whether or not you were running in the JVM or not. So there's this call, you may or may not be aware of it, called gwt.isScript. And so a lot of times people would write code where they would say, if I'm in script mode, which means I've been compiled to JavaScript, run this set of code. But if I'm actually in the JVM and I'm running this bytecode, you have to run this set of code, because usually you're going to do something like access some classes that can't be translated to JavaScript, for example. And so this caused a major headache, because whenever someone created a library, like if I created like a JSON library for GWT, I'd have this stuff sprinkled all over within the code. So it kind of created a mess in the code. You'll also be able to debug mobile apps on Android. So this is something you could never do before. You could fire up your GWT application, run it on Android, set a breakpoint, and debug Java that's running on Android as a web application. So let me switch and show you a demo of this. So here's a small application called the Silver Comet. Silverlight. That's a Freudian slip. Called the Silver Comet. It's basically a half marathon that's in Atlanta, and Kelly Norton, who is one of the Atlanta engineers, he used to run this marathon. So it's graphing times of people who ran the marathon. So if I type stuff like, you can get like this little pop-up here, you can click on stuff, and it will kind of show you what that person's time was. And so if I look at this in the JavaScript inspector, or the web inspector in Chrome, you can see that's basically compiled JavaScript here, right? And this is compiled in pretty mode, so I mean, in theory, you could debug it like this, but it's kind of annoying. So now what I'm going to do is this is running under Super Dev Mode, so I'm going to go back to the root, and I get this little help page, and it says, drag these bookmarklets up to your bar up here. So rather than install a C++ plugin, all you really do is you drag a bookmark up there. So now I'm going to go back to the application, and I'm going to say dev mode on, and I have a little button here and it says recompile. So it's compiling the app, and just like that, less than a second, it actually recompiles the GWT app. That's a full compile, because it's a non-optimizing compile. And so now, if I open up the source, you can see that it's still JavaScript, because I haven't turned on Chrome support. So what you do is you go down here to this little tiny gear icon, and you come up here and you say enable source maps. So now I'm going to refresh the page, and then bring up the inspector again, and hopefully, oh, that's right, sorry, you gotta compile it again. Okay, so now if I click the source map, so now I have Java code in the browser. And so, for example, let me see if I can find the one of the classes here. Maybe model. Let's see here. Let's see, update index property fixes. Alright, maybe I'll just do this one right here. So there's a little loop here where it's trying to render the histogram, and I'm going to put a breakpoint right there. Let me move this down a little bit. Let me just recompile it, because I think it only renders the histogram once. Okay, so now it's paused because I hit a breakpoint down here in Java. So now if I hit play here, I can proceed. So you can actually debug Java code directly in your web browser. But there's more you can do. For example, I can come here and I can say DOM breakpoints, or say event listener breakpoints. So when somebody, let's say, they click, I'm going to trigger a breakpoint. So I'm going to come up here and click on that. Or click. First I got to find a place that's clickable. Hold on. Oops. Oh. I got to find something instead of click listener. Hold on. Let's try this. Okay, maybe this one. There you go. So now you can see it actually broke into JavaScript code. This is a JSNI method, and I'm actually inside of a JavaScript method within GWT. And so I can actually step through that. This is something you couldn't do before. It's basically going between, there's it running the scheduler, there's running flushing scheduler stuff, running the uncalled exception handler. But if I keep stepping, eventually we'll get down to the actual method to handle this. There's a script call. Okay. There it is, handle event. So if I click this, it's probably gonna, the next thing's gonna be probably a listener callback. There you go, handle event. So, I mean, this is just an example, but let's say you were in a large code base, you had no idea what bit of code was like handling when someone like clicked on one of these things. You could set a breakpoint and then you could trace down from the point of the top of the event handler and eventually find the class that was dealing with it. That's something you could normally not do with the existing debugger. Let me go back to my presentation. So that's Super Dev Mode, and we currently call it experimental because although it has worked for a large number of apps that we've tried it on, there have been a couple of pathological cases where people have reported like 30-second or 90-second compiles, even on apps that are smaller than the ones that we're compiling with and getting like speedy compiles with. And so there are probably some pathological generators, it might be UI binder, it might be RPC, that we haven't figured out yet that are actually chewing up a non-trivial amount of time. They're not, basically, their cache is broken somehow. Like they're supposed to not regenerate their code on second and third compiles unless you've changed the original code, but somehow the cache is failing. So, but I would encourage you to play with it. It's in GWT 2.5, so check out the examples and let us know if there's anything broken on your app. Okay. Next thing is Elemental. How many people have heard of Elemental? Okay. So what is Elemental? So this is another story of us not being able to keep up with the web. So in the old days, we were tied by the least common denominator, which was IE6. And so we really did not add too much to the GWT API as far as the DOM or HTML5 APIs were concerned, because we always had to have some kind of fallback for IE6. And then at a certain point, we got some sense knocked into us and said, okay, we should just drop IE6. At least we should not always promise that whatever APIs we add to GWT, they will always be guaranteed to work with IE6. And so we've added a lot of new stuff like Canvas and like DOM storage and things like that. And those don't work with IE6, and we're not adding fallbacks to support IE6. So you just have to know, if you use these features, don't expect them to work on the older browsers, or you have to write your own workaround for them. But even though we did drop the idea of targeting this really old legacy browser, we're still getting inundated with new APIs. Like literally, like every 3 or 4 weeks, the major browsers are adding new APIs, primarily Firefox and WebKit-based browsers. Just to give an example, you have WebGL, you have WebAudio, WebSockets, WebRTC, which is like creating local UDP connections, getting access to the camera, doing video teleconferencing. You got WebIntents, you got the Shadow DOM, you got IndexedDB, file APIs. I mean, not a week goes by. Recently added pointer lock and the gamepad API. So if you want to do a video game and you want to support like Nintendo style controllers, there's now an official HTML5 API for that. And the GWT team just does not have the resources to keep up with all this stuff. And we had to find a new solution for this. And so the solution is to actually take the IDL files used in the C++ implementation of the browser themselves and auto-generate the libraries from it. So no longer with Elemental will we hand code like JSON method wrappers for Canvas APIs or WebGL or SVG. Instead, we just pull down the latest trunk from like WebKit or Firefox. We get out the HTML5 IDL files, and we run a script, and poof, out comes this Elemental library. So a couple things to know about the Elemental library. It's designed to have practically zero overhead, meaning it compiles to nothing. So if you write some piece of code, like create this SVG element and set this animation on this thing, the output should be exactly as you had written it by hand with JavaScript. There should be no Java overhead to it at all. But we went a little bit further than that. we also added new collections classes. So we thought, if people are going to start using this library, which is kind of a break from some of the other libraries in GWT, they might also want to look at really optimal to-the-metal collections classes. And so we designed a set of those in Elemental. It gives you like arrays and maps, and arrays of integers and arrays of numbers, and maps from string to numbers and things like that, that don't require boxing integers and floats and things like that. And when they are compiled, they translate down to JavaScript that's extremely efficient. Again, almost as if you had written it by hand in JavaScript. Very, very efficient. But of course, people want to run code that runs not just in the browser, but on the server. So we basically provide a library, and you just use it. And if you're in a server or a shared code context, or basically a Java VM context, there's other implementations of them that are not in JavaScript, that are in pure Java. So you can use the library safely between server and client code. We also added a optimized JSON library. Again, it works on the server and on the client, and it melts away basically to nothing when you use it. So let me show you a demo. One thing I just wanted to point out is that if you've got an existing legacy GWT app, Elemental library is probably not the best thing for you, because you've already kind of invested in widgets and UI binder and MVP and all sorts of kind of stuff. But if you're programming a new application for like a mobile device, like an iPhone or an Android device, and you want it to be as small as possible because it has to load up over a cell network, and you've got a device like an iPad 1 with only like 256 megs of heap memory, then you want it to be like a really, really tiny, efficient application. This library is an excellent library for doing that because the overhead is very low. So let me see if I can show you a code size. Oh, and okay, my IDE has disconnected. I have to restart it. Can't contact my license server at Google, so it stinks I don't have a license for it. So what this demo I'm going to show you does is essentially it's a combination of Elemental and Super Dev Mode. So what I've done is I've written a servlet that will take a HTML page, it's a servlet filter, and if it sees a script tag in it, and the script tag says type equals text/Java, not text/JavaScript, but text/Java, it will take the code in there and it will extract it out, automatically generate a GWT XML file for you, automatically write an on-module load function for you, stick that code in there, run it through the Super Dev Mode server, compile it to JavaScript, then replace the script tag in the original document and shove it back in the page as if it was handwritten JavaScript. So the overall experience should be almost like writing JSP code, where you just edit some inline Java code within the web page itself, you hit refresh, and boom, you're there. And so, here's an example. First, let me start it up. And I'll start with a simple example. Am I using up too much of your time? Okay. So here you can see I have a script tag, and rather than say text/JavaScript, it says text/Java. And what's in here looks like JavaScript code, though. It doesn't look like Java code. But in fact, it is Java code. And I can prove it to you by bringing up my completion here with my IDE. There you go. And so I got regular Java code completion here, right? And so there's application cache API. How many of you guys know off the top of your head the HTML5 app cache API? It's nice to have Java completion in there that you normally won't get if you're just writing JavaScript by hand. So this is Java code. So just to show you a more elaborate example, here's one that implements the new WebRTC API. So the WebRTC API, real-time, is for real-time media, basically allows you to get access to the camera and even to set up like conference calls like Google Hangouts. And this is basically the inline code I've added to do it. And so let me see if that will work. let's get out of here. Let's see, what is it? Camera. Load that up. So it's asking for permission for the camera, and hopefully it will show up. It was working a second ago. Let me reload it. Okay, let's see here. I must have did something to break something. Well, it was more impressive when. All right, let me go back to this one. I don't know why that's not working. But you did see it prompt me for access to the camera. Okay, there's the one with the window.alert. So, like for example, just to show you that this is really recompiling it on the fly, I'll go back in here to HTML. I'll say hello to. Come here, hit refresh, and it says hello to. So the experience there is almost as if you're just editing HTML in like a text editor, and you just write inline Java code, and it compiles it like that instantly, shoves it back into the page, and you don't have to worry about setting up a GWT module. So that's Elemental, and that's Elemental plus Super Dev Mode plus my own